Welcome back to our session. We're still talking about the application of rules in terms of oxidation numbers. But now we want to try and keep track of the changes in oxidation numbers that occur when a reaction takes place and try to make sense of the big question that we're going to actually pose. Right. So we are going to look at redox reactions now, right? And in the context of oxidation as well as reduction, I have reactions, but we shall try and arrive at the processes of oxidation and reduction with reference to oxidation numbers of a particular substance in a reaction. Right. So the big question now that we want to pose is that have you ever thought about exactly what happens, what does a change in oxidation number tell us about the substance in a reaction? So in a chemical reaction, there is a lot of changes that happen in terms of the electrons of the substances that are forming, the atoms that are forming new substances when we form product. So we want to try and find out what happens in terms of oxidation numbers when a typical reaction does take place, right? So that's the big question for now. Now we shall look at the context of combustion of magnesium. So combustion is actually, put simply, a process which involves the burning of a substance in a lot of oxygen. Okay, so this reaction happens completely, or this reaction will only take place until all the magnesium in this case has burned. So we're told that we consider a reaction involving burning a piece of magnesium ribbon, which actually burns with a very bright flame, okay? And then this magnesium ribbon burns completely, all right? Now, here's the balanced equation of reaction between the reaction between magnesium and oxygen to give us a product, which is magnesium oxide. Okay, so what do we know? We know that neutral atoms or molecules formed an ionic substance, which is magnesium oxide. So this is a formula unit of magnesium oxide. Now this formula unit is actually based on a cation and an anion of magnesium 2+. So where does this magnesium 2+ come from? Let's go back to our rules of assigning oxidation number. We ask ourselves, okay, magnesium as a pure substance, in which group does it occur in the periodic table? We find it in group 2. So in terms of the rules of assigning oxidation numbers, all group 2 elements have an oxidation number of +2. Hence we are saying the formula for the cation of magnesium is 2+, which in this formula unit, which is a compound, right? And then the oxygen, always in a combined state, it's always O2-. So this is what we know by now, right? And then it goes further here and says we want to apply the rules for assigning oxidation numbers to all the atoms in the balanced chemical equation, which is what we have done. We are saying that in this magnesium oxide, right, the total oxidation number is equals to 0, right? The unit oxidation number of oxygen in its combined state is -2. So if there is only one oxygen, the total for oxygen is -2, okay? What about that of magnesium is +2, right? To give us a total of 0, okay? Right, and then also in terms of the rules or assigning rules for oxidation, this is a molecule of an element. We know that every molecule of an element has a total of 0, okay? And also what do we know? We know that every atom of an element, its oxidation number is equals to 0, right? So these are some of the rules that actually must come to mind, right? Okay, now here is the balanced equation of reaction. Now the balanced reaction, what does it tell us? It tells us about the stoichiometric ratio in which these substances react with each other. And always think about the mole. Then we are saying that 2 moles of magnesium reacts with a mole of oxygen to give us 2 moles of magnesium oxide. So the ratio is 2:1:2. So this is basically the stoichiometric ratio in which they react. What else are we saying? If we are to keep track of the changes in the oxidation numbers, we know that magnesium as an element has a unit oxidation number of 0, okay? While on the other side, in its combined state, we managed to derive that magnesium, because it's a group 2 element, a group 2 alkali earth metal, in its combined state, it will have an oxidation number of +2. So there is a change in oxidation number of magnesium from 0 to +2. That can only be explained in terms of the electrons lost by magnesium. And there's an electron deficiency. Immediately we start to talk about the unit oxidation number of +2. So how many electrons were lost? 2 electrons. So there was loss of electrons for magnesium, which caused the change in oxidation number from 0 to +2, right? Okay, now let's focus our attention on oxygen. Oxygen, as a molecule of an element, the total is equal to the unit oxidation number, which is 0, because it's an element, right? And then on the other end, we have assigned oxygen -2, because it is in its combined state, okay? And this is not a peroxide, okay? So in its combined state, we know this rule that says it's going to be -2. So the change in oxidation number for oxygen from 0 to -2, it means oxygen became electron rich by gaining 2 electrons. So there was gain, right? Okay. Now, if we are to, for argument's sake, look at the combustion of magnesium, you know, by making reference to the oxidation numbers, we've seen the changes that have taken place. Okay, so in the combustion of magnesium, there is a transfer of electrons from magnesium to oxygen. So this is the main point. What are we saying? When we talk about a transfer, there is some kind of a donor-recipient type of a relationship. So if somebody gives, somebody must gain. But whatever is given must be the same as what is gained for a transfer to be fair. Okay, so if in this case magnesium lost, whatever magnesium lost, oxygen should have gained the same amount. Okay, so that's the transfer, right? Okay, so this transfer of electrons is represented by 2 half reactions, which is our main point that we want to arrive at. So there's an oxidation half reaction which has to do with the loss of electrons. Okay, what does oxidation tell us? Okay, it tells us that magnesium changed its oxidation number while it was an element. Its unit oxidation number was 0. Okay, after the reaction, when combustion had taken place, it became +2. Okay, so the reason why it became +2 is because it lost 2 electrons. So if you check, the 2 electrons are actually the negative charges that were actually lost. Okay, so if we can just to correct that. Okay, we are saying that. Okay, that's the pen. All right. So this is -2 for oxygen. So this, if you say -2, okay, +2, it gives us that 0. Okay, so it means magnesium lost electrons from an oxidation number of 0 to +2. Okay, and then also we are saying the opposite happened to oxygen. There was a process of reduction. The oxidation number decreased. Okay, when the oxidation number decreases, it means the substance has gained electrons. Okay, so it became more negative or less positive. While that of magnesium became more positive, there was an increase in the oxidation number. I think that's the main point. So the gain of electrons makes the oxidation number of oxygen to change from 0 to -2. Right. So this is the gain of oxygen. And then this half reaction is referred to as a reduction half reaction, right? So the oxidation and reduction half reactions are very important in as far as the transfer of electrons. So in any reaction where there is a transfer of electrons, there is oxidation and reduction taking place simultaneously. This is called a redox. So redox actually consists of that part, which is oxidation, okay? Oxidation, which has to do with the loss of electrons, okay? And then it also has to do with the reduction, okay? So reduction and oxidation is what gives us a redox. This one has to do with the gain, right? That's the main idea, right? And then a small coil of copper wire is placed in a solution of silver nitrate. So we've got copper in a solution of silver nitrate. After a short time, there is an observation that is made. The solution turns blue in color, and silver, a white deposit appears on the copper. Okay, so this is what it looks like. Okay, so if we've got a copper wire, you can see the copper wire there, right? And then it is placed in a solution of what? Silver nitrate. Okay, chemical formula, very, very important, right? And then we've got our copper there. That's our copper wire. Okay, right. This is the observation that is made. And then in terms of the chemical equation that takes place, copper reacts with silver nitrate to give us copper nitrate and silver. Okay, identify the oxidation and reduction half reaction by assigning oxidation numbers. Right, what is clear here, copper as an element, it has an oxidation number of 0. But on the right hand side, when we trace copper, it has an oxidation number of +2. So what exactly happened to copper? Copper, if the oxidation number increased, it means copper underwent some loss of electrons to give us copper 2 plus 2 electrons. Okay, so for copper to change from 0 to +2, there was oxidation, okay, which is the loss of electrons, right? And then again, we can talk about silver. But what is important before we talk about silver, the nitrate is still the same on the left and on the right, okay? So we can immediately say, okay, if this is the half reaction for copper, this is what we got. We got copper, its oxidation number increased. It can only be explained in terms of the loss of electrons, okay? That's our oxidation half reaction. And then in terms of silver, in this combined state, we know the nitrate ion is -1. So silver in this case is +1, and then on the other end, it's 0, right? So we can immediately say, okay, what happened to silver? Silver underwent a decrease of oxidation number. In other words, it became more negative, or sorry, it became a less, it decreased from +1 to 0. So we can say Ag plus, okay? That's the silver on the left-hand side, which is the +1, plus an electron, all right? And then this gives us what? Silver metal, which has got an oxidation number of 0. So this is the oxidation half reaction, which has to do with the loss, okay? And then this is reduction, which has to do with the gain of electrons. So these are the big ideas, all right? So in summary, we are saying oxidation numbers are used to identify when electrons are transferred. So transfer has to do with loss and gain subsequently. And in a nutshell, we are saying reduction involves the gain, and then oxidation half reaction involves the loss of electrons. Right. So that's as far as the big idea of a redox reaction, which actually consists of both oxidation and reduction taking place simultaneously, wherein there is a transfer of electrons. We shall need more practice on this, so try to look into more and more problems that involve oxidation numbers so that we become comfortable. So that's the time we had for today. It's cheers and bye-bye for now.